Assalamu alaikum everyone. I hope you all will be fine. Today we'll discuss about the halogenation of alkanes. So let's see that what happens in this reaction. Here is the halogenation. Halogenation means the introduction of halo group. Halo group to the alkanes. Now, what are halogens? Fluorine, chlorine, bromine, and iodine. These gases are in halogens. These are halogens, okay. Group 7 members are called halogens, okay. And the introduction of these halogens to the alkanes is called the halogenation of alkanes, okay. Here the introduction of halo group, or you can say the introduction of halogens to the alkanes is called halogenation. Remember one thing, this is also a substitution reaction of the alkanes, in which the introduction of the halogen to the alkanes takes place. Here fluorine, chlorine, bromine and iodine are present. They are halogens, okay. So what will happen, and the order of reactivity of the halogens is, here is fluorine, that is more reactive as compared to chlorine. Chlorine is reactive as compared to bromine. Bromine is reactive as compared to iodine. And this is the order of reactivity. Okay. Here fluorine is most reactive. Okay. And iodine is least reactive. And we avoid such kind of reactions which are most reactive. In case of fluorine, if we are taking it in the halogenation of alkanes, or you can say if we are introducing the fluoro groups to the alkanes, it would also be explosive reaction, okay. And we also avoid such kind of reactions which are explosive. So fluorine will not be carried in the halogenation of alkanes. And in case of iodine, this is the least reactive among all of these. We also avoid such kind of reactions which are too slow and also gives us some mixture of products. And in case of fluorine, it gives us mixture of products, and the you can say the purity of our product will be affected due to its most reactive nature. But in case of iodine, this is, as you know, that this is least reactive among all of these. So this would be, and the reaction with the iodine will be very slow. So we also avoid such kind of reactions. So remaining two, fluorine and bromine, these two can be used in the halogenation of alkanes, okay. When we are using chlorine, it would be chlorination. When we are using bromine, it would be bromination of alkanes or chlorination of alkanes, okay. Say I am taking chlorine, okay. We can also take bromine. So when we are taking chlorine, it would be chlorination of alkanes, okay. You can also take bromine, okay. So in the case of chlorination, what will happen here is, or methane. We can also, methane is included in the lower alkanes. You can also take higher alkanes, that is your choice. Here in case of chlorine, and in the presence of UV light, what will happen? The complete chlorination, or you can say the complete halogenation of alkane will take place. While in the case of nitration, the nitro group, the replacement of hydrogen, only one from any of the carbon side, one hydrogen will be replaced by the nitro group. But in case of chlorination, or you can say in the case of halogenation, the whole of the hydrogens will be replaced by the chlorine or bromine, which halogen we are taking. Let's see what will happen in its mechanism. When we are discussing about its mechanism, so let's see that what happens in its mechanism. When we discuss about its mechanism follows this chlorination follows the free radical mechanism. Okay, free radical mechanism. What will happen in this? In the presence of UV light, what will happen? Here is the chlorine molecule. I am openly write its structure. Here is the chlorine gas molecule, and here is, you can say, open structure. And in case of when it's in the presence of UV light, this single electrons moves to one chlorine, and the single electron moves to the other chlorine, and two chlorine radicals are formed. These free radicals are very reactive due to the odd number of electrons. These free radicals are very reactive. They will react with the methane and gives us our product. So let's see how they give us our product. So for this mistake in the initiation, what will happen? This is the initial step 1. In this step, the free radicals of the chlorine, they are formed in the presence of UV light, and it forms two free radicals of chlorine molecule. And in the second step, that is propagation, what will happen? This, here is methane, and here is our free radical. Now what will happen? In the presence of UV light, this free radical abstract this proton, this single electron moves to the carbon, and here the here is methane free radical is formed. Okay, is formed. Okay, and this will be in the form of HCl formed. And in the third step, that is termination. Okay, this is the last step in which the whole of these hydrogens of the carbon will be replaced by the chlorine atoms. So what will happen in the termination? Now this free radical came here, its open structure, and here again the molecule of chlorine is taking, and here in the presence of UV light, what will happen? The free radical of this is formed, okay, in the same step, and in the same step this free radical will attack over here, and it forms here is chloromethane. Okay, this is chloromethane. Now in the next step, in the whole of this step, this whole reaction carried out in the presence of UV light. Okay, what will happen? Again, a free radical is formed, and this free radical will attract this hydrogen, and this single arrow here is free radical chloromethane is formed. And in the next step, and that hydrogen will react with that and will be removed in the form of HCl. Now what will happen? That this chlorine free radical molecule, free radical, this will attack over here and it will form dichloromethane. Dichloromethane is formed. Next, what will happen? Here another free radical is formed. Here you can see the arrow. Here is the single arrow, okay, not a double-sided arrow. In single arrow shows the single transfer of electron, okay. The free radical is formed and this free radical abstract this proton and it forms again free radical and again free radical. From that they will attack over here and forms trichloromethane and here is hydrogen. Now what will happen? Again free radical formed and simultaneously that free radical also abstract that proton and trichlorofree radical is formed. Now what will happen? The free radical from this chlorine molecule, this will attack over that carbon and forms carbon tetrachloride. Okay, here one carbon and all the 4 hydrogens are replaced by the chlorine atoms. So this is carbon CCl4 or you can say carbon tetrachloride. And this was all about today's lecture. Thank you.